In this presentation, we will be discussing the top 10 information technology trends for 2016. Technology is changing at a rapid pace, and end users struggle to remain current. Not only are people struggling with their devices, but they are often challenged with navigating new platforms as well. New technology offers benefits and challenges that affect individuals of all ages, all genders, all races, and in every corner of the globe. New technology trends offer changes in the way that we live, think, and behave, but this often comes with a steep learning curve and many challenges. Let's first discuss the trends, and then we'll address the challenges. One such trend is called the device mesh. A device mesh is a web of wearable and mobile devices and Internet of Things sensors that people use to find information or communicate online, and have led to an increased number of sensors embedded in many technologies and devices that we use personally and professionally. They become smarter as they gather more data on our daily patterns. Experts predict these sensors, which tend to work in silos today, will increasingly work in concert, leading to an even greater insight about our daily patterns. The ambient user experience refers to the devices and sensors' ability to gather more contextual data as described in the device mesh. The challenge will be the application design, anticipating this level of device synchronicity and collaboration, for lack of better framing. Experts claim that the device and sensors will become so smart they will be able to organize our lives without us even noticing they're doing so. Though not a new trend, 3D printing has caught its stride now that companies like Tesla are using it to build engine parts, and SpaceX is using it to create rocket parts. 3D printing is already building better applications of the technology to biological material, and food will follow. Here are 12 examples of how 3D printing is currently affecting our lives in medical technology. 1. Blood and tissue. Researchers at Harvard University are making great progress in bioprinting blood vessels, a crucial step towards printing tissues with a blood supply. The lab of Dr. Jennifer Lewis designed a custom-built 3D printer and a dissolving ink to create a swatch of tissue containing skin cells interwoven with structural material that can potentially function as blood vessels. Prosthetics. Creating traditional prosthetics is very time-consuming and destructive, in that modifications to the prosthetics would destroy the original molds. Moreover, the cost of traditional prosthetics is a significant barrier to those without significant resources. Researchers at the University of Toronto, in collaboration with Autodesk Research and CBM Canada, use 3D printing to quickly produce cheap and easily customizable prosthetic sockets for patients in developing worlds, particularly Uganda. Similarly, Not Impossible Labs, based in Venice, California, took 3D printers to Sudan, where the chaos of war has left many people with amputated limbs. The organization's founder, Mick Ebeling, trained locals how to operate the machinery, create patient-specific limbs, and fit these new, very inexpensive prosthetics. Drugs. Lee Cronin, a chemist at the University of Glasgow, wants to do for the discovery and distribution of prescription drugs what Apple did for music. In a TED talk, Cronin described a prototype 3D printer capable of assembling chemical compounds at a molecular level. Patients would go to an online drugstore with their digital prescription, buy the blueprint and the chemical ink needed, and then print the drug at home. In the future, Cronin suggests that we might not sell drugs, but rather blueprints or apps. Progress is being made in this direction as Louisiana Technical University researchers have printed biocompatible, biodegradable devices for delivering bone cancer medicines. The heart valves. Jonathan Butcher at Cornell University has printed a heart valve that will soon be tested in sheep. With a dual syringe machine, he was able to print a combination of oligonate, smooth muscle cells, and valve interstitial cells to control the valve stiffness. Ear cartilage. Cornell's Lawrence Bonassar used 3D photos of human ears to create ear molds. These molds were then filled with a gel containing bovine cartilage cells suspended in collagen, which held the shape of the ear while the cells grew their extracellular matrix. Bonassar and his team have since gone on to 3D print intervertebral discs to treat major spinal complications, while researchers at Princeton have 3D printed their own collagen ear, this time with built-in electronic components for superhuman hearing. Medical equipment. Already, 3D medical printing is occurring in poverty-stricken areas of the world, due to the ability to manufacture items that may not be as easy to get or expensive to obtain by traditional means. Groups like iLab Haiti have taken to 3D printing umbilical cord clamps for local hospitals in Haiti. Cranium replacement. A team of Dutch surgeons in the University Medical Center in Utrecht replaced the entire top portion of a 22-year-old woman's skull with a customized printed implant made from plastic. This story has been replayed in China, where a man with a crushed skull was given a tailor-made, 3D printed titanium replacement, and in Slovakia, in which a different man with a brain damage received a similar 3D printed treatment. Synthetic skin. James Yu at the Wake Forest School of Medicine in the U.S. has developed a printer that can print skin straight onto the wounds of burn victims. With the ability to scan a wound, the printer can then fabricate the appropriate number of skin layers to fill the wound. Yu's research was successfully demonstrated in the viability of a 10-centimeter piece of skin transplanted onto a pig. It has since been funded by the U.S. Army to use the technology to treat wounded soldiers. Organs. Organovo recently announced the commercial launch of their bioprinted liver assays, 3D printed liver cells that are able to function for more than 40 days. While at the moment the product is being used for testing new pharmaceuticals, Organovo's top executives and other industry experts suggest that within a decade we will be able to print solid organs such as liver, heart, and kidney. Hundreds of thousands of people worldwide are waiting for an organ donor. Imagine how such technology could transform their lives. Tailor-made sensors. Researchers at Washington University in St. Louis have used scans of animal hearts to create printed models around which stretchable electronics were wrapped. This silicone device can be peeled off the printed model and attached onto a human heart for the perfect fit. The electronic sensors can detect oxygenation detectors, heart strain, and temperature. The next step is to enhance the electronics with multiple sensors, including those that measure acidic conditions to detect blocked arteries. Medical models. A group of researchers in China and the U.S. have printed models of cancerous tumors to aid in the discovery of new anti-cancer drugs and to better understand how tumors develop, grow, and spread. Creating patient-specific models from CT and MRI scans expands from medical research into practical application with the ability to prepare doctors for surgeries, thus drastically reducing surgery times. Taking this one step further, there are numerous examples of using medical scan data to 3D print implants tailor-made to the patient. Bone. In 2011, Professor Susmita Bose of Washington State University modified a pro-metal 3D printer to bind chemicals into a ceramic powder, creating intricate scaffolds that promote the growth of bone in any shape. Professor Bose's goal is to, one day, be able to implant the bone scaffold with the bone growth factors in such a way that the implant is dissolved by the natural bone material and even load-bearing bone structures. By 2020, 25 billion devices will be generating data about almost every topic imaginable. This is equal parts opportunity and challenge. There will be a plethora of data, but making sense of it will be the trick. Those companies that can harness the power of this tidal wave of information will leapfrog competitors in the process. To an increasing extent, technologies will be able to not only collect information, but learn based upon it. In the process, much of the initial analysis that has typically required humans can be done by machines, elevating the analysis process. People will need to engage at a higher level as a result. This is where the theory and development of computer systems will be able to perform tasks that normally require human intelligence, such as visual perception, speech recognition, decision-making, and translation between languages. The potential for robots to continue to master and surpass humans in their ability to undertake human tasks will increase rapidly. Perhaps the most prominent example is the autonomous car, which leverages learning from autonomous vehicles that have been used within controlled environments for years. Masdar City in the United Arab Emirates is one of the prominent controlled environments. Moving beyond controlled environments into non-controlled environments, including the airspace that drones occupy, will require further advances. All organizations should now assume that they are in a state of continuous compromise. To address this, security professionals must reimagine their approach to security and create adaptive architecture that protects against advanced attacks. In the report Designing an Adaptive Security Architecture for Protection from Advanced Attacks, expert analysis recommends security professionals 1. Switch to a continuous response mindset, 2. Invest across all phases of the security lifecycle, and 3. Select vendors who provide integrated prediction, prevention, detection, and response capability. Comprehensive protection requires an adaptive protection process integrating predictive, preventive, detective, and responsive capabilities. Companies are pushing the envelope on making technology mimic human brains. Prominent examples of this action include Facebook FB 3.36, deep face facial recognition technology. More apps are being built to be plugged together, and the value of the combination is much greater than the sum of the parts. As Lyft has integrated with comparable offerings in their countries, its ability to expand its offerings for traditional customers traveling abroad, and the reverse has meant faster growth with minimal cost implications. The Internet of Things is a system of interrelated computing devices, mechanical and digital machines, objects, animals, or people that are provided with the unique identifiers and the ability to transfer data over the network without requiring human-to-human or human-to-computer interaction. As we look over the list of information technology trends in 2016, it's hard not to be excited about the possibilities of the technologies we have and the promises of the future. It's also hard not to consider the challenges we face because of the speed of the changes brought forward in the digital age. A new study by a researcher at the San Diego Supercomputer Center at the University of California in San Diego says that by 2015, the sum of the data asked for and delivered to consumers on mobile devices and to their homes would take more than 15 hours a day to see or hear. That volume is equal to 6.9 million gigabytes of information a day, or a daily consumption of 9 DVDs worth of data per person per day. That is information overload. The art of being social has declined, and all participation on the social media has increased. However, the younger generation finds it more comfortable to communicate on a mobile device or app than to communicate face to face. And we are now faced with a society that is virtually sociable. However, they do not feel safe communicating on a more personal level. Another challenge we will have to face is as these smart devices become smarter, they will rely less upon us as the operator, and they will become their own operators. What will be left for humans to do? As we explore artificial intelligence and machine intelligence surpasses human intelligence, we will see human relationships become more involved with robots and then cyborgs until humanity becomes extinct.